Hello guys, welcome to Unacademy Studios Bridge. Here I have come up with the third and the final part of cantilever beams, slope and deflection, slope and deflection in cantilever beams. This is the third and final part. If you have not already watched part 1 and part 2, I would recommend you to go back and first of all check my other videos in this particular series. They are available in the playlist Slope and Mechanics of Solids, Slope and Deflection Cantilever Beam. You just go to Unacademy Studios Bridge and then search for this particular playlist, just in case if you have not completed other two parts, because we are literally done with all type of problems that are there in cantilever beams. We have already discussed about the suitable methods for any given problem. I'm just going to take few additional problems for your better understanding, for your better refinement. I'm just going to take few additional problems to solve. Otherwise, we have already completed the discussion and we have already completed the tricks and the methods that you're going to use in cantilever beams. Just in case if you are new to me, just in case if you are attending me for first time, here is a brief introduction. Here is a brief introduction about myself. I'm Marut Tiwari and I did my masters from IIT Kharagpur. I've been a recipient of multiple awards at IIT Kharagpur, and I've cracked GATE multiple times, and I'm also an author of a comprehensive book, GATE in 75 days for entire mechanical engineering. And this is, I'm proud to share this with you, that this is one of the best sellers in GATE segment. And my dear friends, now I'm associated with Unacademy. Unacademy is having number of outstanding educators. So if you just go for Unacademy Plus subscriptions, then you can avail the courses offered by all these educators out there. Unacademy has a lot of features and a lot of reasons for you to direct your GATE preparation from Unacademy Learning app. And one such feature is that so many classes are available. So many classes are available, so many courses are available to be experienced for totally free, for totally no cost. All right, and you have a flexible schedule. Like, it is up to you when to watch and when to follow which course. All the courses are permanently available out there, and you can watch the courses in English also, and you can watch the courses in Hindi also. You can choose the language of your choice. Just in case if you're comfortable for attending classes in Hindi, you can go for it. And just in case if you're not comfortable in attending classes in Hindi, then you can rather attend the English ones. Even other local languages are available as a medium of classes. And one beautiful feature of Unacademy is that you can watch and you can practice and take and retake number of things at any given number of times. There is no limitation. Once you subscribe, it's all for your package. Like, you can be watching it, you can keep watching it as many times as you wish. You can keep watching it, like, unless you feel that you have that enough command over that particular topic. You can chat with the educators, you can participate in interactive polls, and you can learn anytime and anywhere. So as I said, a lot of convenience is there, a lot of flexibility is there, a lot of freedom is there, but at the same time you also get a classroom like environment. So this is one of the revolutions going on in learning and coaching field. And as far as packages are concerned, we have number of packages. You can subscribe for a monthly package, you can subscribe for a package which is for 3 months, you can subscribe for a 6 months package, you can go for 12 months package, you can also go for 24 months package. The most cost effective package is that for the 24 months. As far as this 24 months package is concerned, the package cost is 40,000, one time payment of 40,000, but if you divide it by 24, effectively it comes down to 1667 rupees per month only. And this is unprecedented. Why? Because 1667 rupees would be probably the cost of, going and coming back from and to the classes. If you are, just in case, if you are attending any institute or something. I'm not just talking about GATE. I'm talking about any other, aspirant preparing for any other entrance exam, that, my dear friends, such a cost-effective learning is rarely available out there. In fact, it can be brought down even further. If you use my code MTLive at the time of subscription, then you get 10% additional discount, and after getting 10% additional discount, the final cost of the package is going to come down to just 36,000 rupees. Alright, final cost of the package will come down to just 36,000 rupees. Now 36,000 divided by 24 is just 1,500 rupees a month. So this is probably unmatchable, particularly if you compare the Unacademy learning courses with such qualitative learning courses out there. Then probably you're never going to get such qualitative learning courses at just 1,500 rupees, effectively 1,500 rupees a month. Similarly, you can go for a 12 months package. For a 12 months package, one time payment of fees is 25,000, which comes down to effectively 2,083 rupees per month. But at the time of subscription, don't forget to use this referral code. If you use my referral code MTLive, then further the cost will come down, and you'll have to pay, rather than paying 25,000, you'll have to pay just 22,500. And if you divide that 22,500 by 12, you effectively pay less than 2,000 rupees a month. So effectively, you pay just less than 2,000 rupees a month. Now this is a win-win situation, because you have convenience, you have flexibility, you have freedom, and you have number of courses to choose from and number of educators to choose from. Alright, so a lot of flexibility, a lot of freedom is there, but at the same time, there is no compromise with the quality. So guys, go ahead, don't hesitate. If you are currently preparing for GATE, and even if you are a third year student and you are preparing for GATE 2021, then I would recommend you to go for either 12 months or 24 months subscription. Alright, in long run, it is going to be cost effective, and it is going to consistently and continuously help you with your preparation. Alright, it is very easy. You just need to go to Play Store, and on the Play Store you need to install Unacademy Learning app. After signing up into the app, you need to choose GATE as your goal, and after choosing GATE as your goal, there are number of packages available. You can subscribe for them, as I have already discussed about them. So go ahead, happy learning. Now let us start talking about the topic. My dear friends, I have already, in part 1 and part 2, I have already discussed about 5 different type of slope and deflection problems in cantilever beams. In cantilever beams, there are 5 different type of problems possible. There is no 6th type here. Alright, I mean to say that whatever I have covered in these 5 types, that is exhaustive. Alright, there is no new problem that can be formulated. Any problem that can be formulated based on cantilever beam, based on slope and deflection of cantilever beam, will be belonging to any one of these 5 type of problems. So these 5 types are totally possible, and these 5 types are going to give you a complete package for slope and deflection in cantilever beams. In part 1 of this series, I have already discussed about solving type 1, type 2, type 3 and type 4 problems, and in part 2 I have discussed about solving type 5 problems. First 4 type of problems I had recommended for you to solve using method of superposition. Method of superposition is a very simple thing. All you need to do is you need to remember 4 standard cases. These 4 standard cases are, by the way, I say it once again to you, that just in case if you are here and if you have not watched part 1 and part 2, then please go back and complete that part 1 and complete that part 2 and then come back to this. Why? Because this is a continuation of part 1 and part 2. Alright, so first of all, you complete those 2 videos and then come here, then only you will be able to connect and then only you will be able to understand. So for type 1, type 2, type 3 and type 4 problems, I had recommended you to use method of superposition. Method of superposition is simple, that any given beam you need to break into a combination of standard beams, and after breaking that beam into a combination of standard beams, then you can use the standard formulas. So what are these standard beams? These standard beams are a cantilever beam with a couple, a point load, a UDL, and a cantilever beam with a UVL. A cantilever beam with a UVL. Of course, in cantilever beams, you are going to have a fixed support at one extreme. And let's say the maximum intensity of this UVL is omega naught and the constant intensity of this UDL is omega. Now, regarding these 4 beams, we have already discussed in part 1 of this series. Part 1, the very first video of this particular series, we have discussed about the theta max values and the y max values. Theta max values, my dear friends, theta max values are, for the first beam, theta max value is m naught L divided by EI. For the second one, theta max value is WL square divided by 2 EI. For the third one, it is omega L cube divided by 6 EI. And for the fourth one, it is going to be omega naught L cube 4 EI. And then the second thing that I told you, was the y max value. What about the y max value? My dear friends, y max value for the first one, for the first beam, y max value is ml square by 2 EI. For the second one, y max value is WL cube divided by 3 EI. For the third beam, the y max value is omega L raised to 4 divided by 8 EI. And for the fourth one, the y max value is omega naught L raised to 4 divided by 30 EI. I emphasized in that first part, that first video also, that please do mug up, do memorize, do absorb these 4 standard cases and these 4 theta max formulas and these 4 y max formulas. In the very first video, my dear friends, I have already discussed about a trick to recall and to reproduce these formulas very quickly. In part 1, I have already given you a trick to very quickly reproduce these formulas, very quickly recall these formulas. Alright, in a matter of minute, using that trick, you can reproduce these formulas. So there is no need to even mug up these formulas. If you remember that trick which I had already shared, then you can produce these formulas in a matter of a minute. In 1 minute, all these 8 formulas you can make. Alright, so method of superposition is going to help you in type 1, type 2, type 3 and type 4 problems. Type 5 problems, I had recommended moment area method. For type 5 problems, which we have covered in part 2 of this series, my dear friends, I had recommended moment area method and I had also solved a problem based on that, where you have varying flexural rigidity. Now, apart from, for first 4 type of problems, apart from remembering these 8 formulas, you need to remember one little concept, one little funda further. And that one little funda is what? That one little funda is that just in case if you get a cantilever beam at which there is a load somewhere in between, and suppose there is no load in the remaining length, suppose there is no load in the remaining length, something like this. Let's say this PS length is small a and this SQ length is small b. Then, my dear friends, this beam is going to turn into a curvature because of the load. Beam is going to bend down, but only this P to S length will turn into a curvature. This S to Q length is going to remain straight. S to Q remain straight. And this is something that I have discussed. In example 2 of part 1 video, I have already discussed such a case. For such a case, because SQ segment is remaining straight, my dear friends, we can write theta q is equal to theta s, and we can write yq here. Now this is yq, and this yq value can be very clearly written. This yq value we can write as what? This yq value we can write as ys, this value, ys plus this thing, and this thing I had already described this in first part of the video, in part 1 of this particular series, that this yq value we can write as ys plus h, and h is nothing but b into theta s. H is nothing but b into theta s. So apart from remembering these 8 formulas, please also do remember this little concept here. Please also do remember this little funda here, that my dear friends, do remember this little funda. This is going to help you to break any beam into a standard beam. Using this little funda, any given beam can be broken into a standard beam. So make sure that you understand this. Just in case if you don't understand this, no problem. You go to the part 1 and watch example number 2. There I have totally explained that how you are getting this. Alright, so just make sure that you're now totally remembering all these 8 formulas, and let's go ahead and try taking up few additional problems. In this slope and deflection of cantilever beams, we have already solved total of 7 problems. As an 8th problem, my dear friends, let me take this cantilever beam which is having a UDL spread in a length of 2.4 meter, and in this initial length of 1.2 meter there is nothing. This UDL has got the intensity 1200 Newton per meter. Alright, and let's say this point is P, this point is S, and this point is Q. The flexural rigidity value of the beam is given to us as 3600 kilonewton meter square, and the question is asking you to calculate the Y max value for this particular beam. Now this beam is very clearly not directly looking to be a standard beam. Why? Because our standard beam has, you see, our standard beam has what? Our standard beam has UDL in entire length. But the beam that I'm taking up as a problem, this beam doesn't have the UDL on entire length. So how do you break it up? How do you explode it into a set of standard beams? To do that, my dear friends, we are going to extend the UDL at the very first. To do that, we are going to, we have this UDL acting in 2.4 meter length, and the UDL is not available in this 1.2 meter length here. So we are, first of all, we are going to extend the UDL. We are going to extend the UDL up to the fixed support, something like this, so that the beam turns into a standard beam. Now you will say that how can you introduce any extra load just like that? Of course, that's not something which is allowed. So I am supposed to compensate for it by introducing an equal and opposite load. Do remember this length where I'm manipulating all these things. This length, my dear friends, is 1.2 meter. This length, this much length is 1.2 meter, and this point is P, this point is S here, and this point is Q. Now I'm going to break this beam after extending the UDL up to the fixed support. I'm going to break this beam into 2 beams. One, the beam with a cantilever, the cantilever beam with UDL throughout its length, the cantilever beam with UDL throughout its length from P up to Q, and this total length is how much? This total length is 3.6 meter, and intensity of UDL is given to you. Plus, so once you consider this entire UDL, that is acting from the top, once you consider this entire UDL that is acting from the top, all right, so that we get one standard beam, one standard cantilever beam with UDL throughout its length of 3.6 meters. And then you consider that green UDL that we have applied from the lower side. So then you consider this green UDL that we have applied from the lower side, and this is what we have. This is what we have. This is acting in 1.2 meter, and this is not available in remaining 2.4 meter length. Now we can very clearly break this beam into two beams, and then, my dear friends, let's call this one as beam 1 and this one as beam 2. Then we can use method of superposition to write YQ, which is also representing Y max, as YQ of the first beam plus YQ of the second beam, isn't it? YQ of the first beam is very simple thing. For the first beam, it's never a challenging thing. For the second beam, we are going to use this straight funda. For the second beam, we are going to use this funda, that if certain length on the free side doesn't have any load, then we can write the deflection at the end point as the deflection at the point up to which the load is acting, plus that length which is unloaded, that length which doesn't have any load, multiplied by the slope at that point up to which the load is ending. So this is, I repeat once again, this is a funda that I described in part 1 of this series, and in part 1 of this series, part 1 of this entire playlist, I have already described, I have already considered one example number 2. There you can go and you can have a mastery over this particular concept. So guys, I'm going to use, for the second beam, I'm going to use this funda. For the first beam, there is no problem. First beam is itself a standard beam. For the second beam, I'm going to write YQ is equal to YS plus B theta S. What is B? B is that length in which there is no load. Now, as I said, for the first beam, it's never a challenge. So let's now write the values. For the first beam, deflection is obviously downward. For the first beam, deflection is downward, and that can be written by a standard formula, which is omega L raised to 4 divided by 8 EI. And for the second beam, deflection is going to be upward. You visualize this UDL here, and then for the second beam, deflection will be upward and it will be straight in this SQ segment. SQ segment will be straight. That is why I have used this YS plus B theta S funda. So it's going to move upward, and then YS and theta S. How you are going to write YS and theta S? To write YS and theta S, my dear friends, to write YS and theta S, you just need to focus on this much beam. To write YS and theta S, you just need to focus on this much beam, and this will once again look like a standard beam. Delete the remaining beam and just focus yourself at this much beam and write YS and theta S just as you'd have written for a standard beam. So just hide the remaining beam and just consider this P to S length as a standard cantilever. So you can use the standard results again. Alright, you can use the standard results again. So let's use the standard results. Let's call this length 1.2 meter as A here. this length 1.2 meter as A. Then we can write ys as what? For UDL, the standard result is omega L raised to 4 divided by 8 EI, and this is upward, therefore I'm taking positive. And then you have 2.4 theta S. What is theta S? Theta S is, again I'm using the standard result, omega L cube divided by 6 EI. Now you know all these values. Let us take omega and also let us take EI common here. If we take omega and EI common here, then my dear friends, we'll be left with L raised to 4 divided by 8, and then we'll be left with A raised to 4 divided by 8, and finally we'll be left with 2.4 into A cube divided by 6. Now you can put all the values, and if you put all the values, then my dear friends, in one line you can get the answer. So omega value is given to you 1200 Newton per meter. Flexural rigidity EI value is again given to you 3600 kilonewton meter square. Let me change it to Newton meter square. And then length of the first beam is how much? The length of the first beam is 3.6 meters. The length of the first beam is 3.6 meters. And what about the length of the second beam? The length of the second beam, the length of the second standard beam is 1.2 meter. So you can put it here 1.2 meter and here again 1.2 meter. And then you can simplify and you can use your calculator to get the final answer. You can use your calculator to get the final answer. I hope you understand. In part 1 of this series, I have taken another example, and I have taken a UDL that is not acting up to the fixed support. So just go ahead and practice as many problems as you can as far as cantilever beams are concerned, because as I said, 70-80% of the times they have been asking cantilever and cantilever only. Why? Because in cantilever beams there are a lot of tricky questions that can be formulated. Let me take one more example. Let me take one example this time from propped cantilever beams. Let me take as a 9th problem. Let me take a propped cantilever beam. Let's say we have this propped cantilever beam. Propped cantilever beam is what? Again, part 1 of this series I have already described, and I have solved a problem also based on propped cantilever, a gate problem. So suppose we have this propped cantilever, and suppose this particular propped cantilever is divided into two lengths, L and L, and at the midpoint we are applying a concentrated couple. At the midpoint a concentrated couple is being applied. So guys, we have this propped cantilever beam here, and in this propped cantilever beam, we have to find out the RQ value, which is the prop reaction. And compatibility condition we have already discussed in part 1 of the series, that compatibility condition of propped cantilever beams is that because you have introduced an extra support at Q, so YQ is equal to 0. Now how do you write YQ? How do you express YQ? To express YQ, I'm going to break this beam into two standard beams. I'm going to break this particular beam into two standard beams. One, the beam with RQ available at 2L length, and another, the second one, the beam with couple acting at the mid. The beam with this couple M acting at the mid. This is point P, this is point Q, and this is point S here. This is point P and this is point Q. Alright, and this much is L and this much is L. So okay, now we can, after breaking this beam into two beams, YQ as YQ for the first beam plus YQ for the second beam, isn't it? Now YQ for the first beam is rather a very simple thing. How about the YQ for the second beam? How about the YQ for the second one, for this one? For this one, my dear friends, you got to use the same funda once again. Which funda? Excuse me for a moment. Which funda? That funda that I have discussed already with you. This one. This one, that if certain length is loaded and remaining length is unloaded, then you can write YQ is equal to YS plus B theta S. Alright, this is something that you must practice, because 2-3 problems you practice and then it will be permanently embedded. It will become a default thing. It will automatically click to you that where you have to use this. Alright, so for this one, you can write YQ is equal to YS plus B theta S, and B is nothing but L. So let me write this. First beam is never a challenge. First beam is never a challenge. For the second beam, we can replace YQ as YS plus B into theta S, and B is nothing but L, isn't it? B is nothing but L. B means that length at which there is no load. So that length is nothing but L. Now, YQ for the first beam, as I said, it was never a challenge. So YQ for the first beam is positive. YQ for the first beam is positive. YQ1 is a positive thing, and you can write it simply as WL cube divided by 3EI, isn't it? So you can write it WL cube divided by 3EI, and this is positive. For the second beam, the deflection is going to be downward. For the second beam, deflection would be downward, and this SQ segment will remain straight. S2Q segment will remain straight. Because the deflection is going to be downward, we use a minus sign here. Now, how can you write YS and theta S? How can you write YS and YS value and theta S value? To write YS and theta S values, you need to focus just as this much beam. You need to focus just at this much beam, only this L length of the beam. Because remaining beam is anyway not having any load. Remaining beam doesn't have any load. So if we focus at this much length, then once again we can use the standard results. And this is the very first standard result. If you hide this much, then that L length is nothing but a standard beam. And for that you can write YS and theta S using the standard results only. So let's go ahead and write them. YS is what? YS is gonna be ML square divided by 2EI, and then my dear friends, we have theta S as simply ML divided by EI is equal to 0. You can now simplify this. EI is a common factor here, so EI is going to get cancelled. EI is a common factor here, so EI is going to get cancelled. Also L square is a common factor here, so other side is 0, and therefore L square will also disappear. Now what is left? We have 2 cube, which is 8. RQ divided by 3 is left here, and remaining thing is minus, so we can take it to that side. L square and EI is anyway cancelled, so we are left with m by 2, and we are left with m. This is nothing but 3m by 2, so we get 8RQ divided by 3 is equal to 3m by 2. We get 8RQ divided by 8RQ divided by 3 is equal to 3m by 2. So from here we get RQ value as what? From here we get RQ value as 9m divided by 16L. 9m divided by 16L. I'm sorry, I missed one L here because L cube was there. So one extra L would be here, and this is how you get the final answer. So my dear friends, I say it once again that if it is itself a standard beam, good for you. If it is not a standard beam, you will have to break that beam into a combination of standard beams, and then you'll have to use the standard results. We have solved a number of problems, but I recommend you to solve a few more problems by yourself to get a better practice and to get a better command. I just hope that you enjoyed the session as much as I did, and I just hope that from my videos and from my sessions you are constructively and positively learning the things. I'll be in the next few days, I'll be making videos on vibrations because a lot of students are demanding for vibrations, and I'll tell you some fantastic tricks to solve natural frequency problems belonging to free vibrations and other variety of problems. Thank you very much for watching this session. Before you wind up, don't forget, if you have already not done it, don't forget to hit the bell icon, because that's the way to get regular updates about my videos and all. And whenever you are subscribing for any package or something, don't forget to use my code MTLive to get 10% additional discount. Thank you very much once again for watching the session. Thank you.